Now I'd like to present my best algebra technique, best algebra tip. Okay, this is good stuff, so you'll want to pay attention. I'm going to show you how to avoid algebra by replacing variables with numbers. Okay, we're going to do this in order to eliminate choices. So in other words, we are converting algebra to arithmetic. Now, remember I said we don't want to answer questions directly. We simply want to eliminate wrong choices. All right. Now, because we're doing that, that's the reason we can get away with sometimes replacing variables with numbers. Let me give you an example. Suppose you were answering this question on the SAT. If 0.1% of x is equal to 10% of y, then x is what percent of 10y? And then the choice is 1 over 1,000, 1,000th of a percent, 1%, 10%, 100%, and 1,000%. Now, the proper thing to do would be to get a general answer, right? That would answer the question for all values of x. All right. However, we don't need that, and we don't want to do any work we don't need to do. Instead, let's pick a value for x and take it from there. Okay. Now, I'm going to pick a value that's easy to work with. All right. What's a number that's easy to find 0.1% of? Okay. I'm going to pick 1,000. It seems that that's probably one of the easiest numbers to work with to find 0.1% of. Okay, so I'm going to pick x equal to 1,000. So 0.1% of 1,000 is 1. All right. Now, 0.1% of 1,000 is equal to 10% of y. So that means we know that y has to be 10 because of the value that I've selected for x. All right. Now let me read the last part of the question using my values for x and y. Okay. So now I want to know 1,000 is what percent of 100. All right. The reason I got 100 was because 10y, 10 times 10, that's 100. Okay. So once again, 1,000 is what percent of 100. Now, isn't that a much nicer question to answer than dealing with all this algebra gobbledygook? All right. So 1,000 is it's 10 times 100, which is 1,000%. So the answer would be E. All right. You see how that works? Now I'm going to give you my best geometry tip, my best geometry technique. Okay? What I would suggest is I would suggest ballpark or approximate the right answer to geometry questions by you look at the picture, okay, and you approximate lengths, areas, and angles. Okay? This will work unless the question says that the figure is not drawn to scale. All right. Hopefully you won't see that in too many places, but if it doesn't say if the figure is drawn to scale, which you can assume if it doesn't explicitly say that the figure is not drawn to scale, then go ahead and try to eyeball and get an approximation for what lengths, areas, and angles are. All right. Let me give you an example of that. Suppose you had to answer this nightmarish question. What is the total area of the shaded portion in the figure? So you can see there I have a square and 5 circles, right? I have the 4 outer circles have a radius of 1. The square is made from radii of those circles. Looks like the square has a length of 2. And then I have this gray area inside the square formed from the 5 circles. Okay? And we have 5 choices: 2 pi over 3, 2 pi minus 4, 6 pi, 8 pi, and pi divided by 10. Now, somebody somewhere in the world probably has memorized a formula for this gray shape. All right. Now, I don't know what that formula is, and I don't care, because if I tried to memorize the formula, I'd probably forget it anyway. It's probably a really confusing, complex formula. All right. Watch this. Let's do the process of elimination. Okay. What's the area of the square? The area of the square is 4, because the area of a square is the side length multiplied by itself. So 2 times 2, so 4. Okay. What fraction roughly do you think the gray area contains of the square? Okay. When I ask students this question, students will typically tell me that it looks like the shaded region, the gray region, is about half the area of the square. Okay, so the square has an area of 4. The shaded region therefore has an area around 2. Okay, so we are going to eliminate choices that are nowhere even close to 2. All right, you see how that works? Okay, so why don't we start from the bottom? And in order to eliminate choices, you have to know that pi is 3-ish. Okay, a lot of people know it as 3.14. Okay, if you at least know that pi is about 3, that'll be good enough for this question. So E, 3 over 10, is that close to 2? That's actually a lot less than 1, so that's out of the running. Okay, 8 pi, that's greater than 24, that's out of the running. 6 pi is greater than 18, that's out of the running. Choice B, 2 pi minus 4, that's about 6 minus 4, so that's close to 2. 2 pi divided by 3, that's about 6 divided by 3, that's also still in the running. All right, so look what we've just done. We've just turned this really scary geometry problem into we have a 50-50 chance of guessing the correct answer between A and B. All right. Now, to satisfy anybody's curiosity, I used calculus to answer this question, and I used some mathematical software, and I believe the answer is B, 2 pi minus 4. Okay, but look how much progress I was able to make just by using the process of elimination. Okay, very, very nice technique. You'll want to remember that one. Now, in order to approximate angles, lengths, areas, etc., there are some things that you're going to want to commit to memory. Okay, the square root of 2, you'll want to memorize the fact that that's roughly about 1.4. Okay, the square root of 3, you'll want to memorize that that's roughly about 1.7. Okay, we've already mentioned pi. You'll want to memorize that that's about 3. Okay, now angles. Okay, if you want to know like this roughly the size of a 30-degree angle, a third of a right angle, right? Because 30 is 1/3 of 90. 90 degrees is a right angle. 45 degrees, that's half of a right angle. Okay, and you can apply this thinking to other larger angles. For example, 135 degrees is going to be a right angle plus a 45-degree angle, right? So that'll be a right angle plus half of a right angle. Okay, so that'll give you a sense of these sizes to help you approximate angles. All right.